Welcome. Thank you for joining me for this review of Chapter 8. So, Chapter 8, when we went through it, there were three kind of big ideas we talked about. Being able to name, add, and subtract polynomials, being able to multiply polynomials, meaning distributing and foiling, and then the biggest idea of that chapter, the idea of factoring. So, those are going to be the focuses as we go through these notes today. So, before we can name polynomials, remember one of the big ideas was writing them in standard form. And what standard form meant to us is it meant combining any like terms that we have. By like terms, we mean variables with common exponents, the same exponent. And then, of course, writing them in order, starting with the highest exponent and working our way down. Okay, now the other big thing was all of this vocab, all right? So this is something, if you don't quite remember some of the vocab, this is a great page to look at, okay? To look at the vocab, recall what all of those words mean. So I have two examples here to go through before we move on. So first, write the following in standard form, the name based on the degree and based on the number of terms. Well, again, to write it in standard form, we're talking about writing the thing with the highest power first. So in this first example, what that means is that negative 2x cubed should be written first because cubed is higher powered than just the 4 itself. So I'm just going to rearrange that. So now it's in standard form. And now let's take a look at naming this thing. So I see a third power, a third degree. Well, it says right here, a third degree is going to be cubic. And then I see that there are two terms. Something with two terms we call a binomial. So this first one is just a cubic binomial. Looking at the next one. So again, the first concern is writing it in order. Well, the 4x squared does have the highest power, but now the other two need to be flipped. This should be a negative 5x next because the x has a higher power than just a constant number. And of course, once I have it in standard form, now I go through and I do the naming scheme again. So degree 2. Degree 2 is right up here, a quadratic. And again, hopefully you remember that one because we literally spent an entire chapter on just quadratics. And number of terms, I count 1, 2, 3 terms. 3 terms is going to be a trinomial. So again, for this, just be comfortable with that vocabulary. Take a peek at that chart whenever you're asked a question to refamiliarize yourself with it. Of course, the other thing is adding polynomials. Now, when you're adding polynomials, literally, you're just combining like terms. So what I usually do is I just look for those common powers. So here, this tells me I'm just adding these together. So I have 5x cubed minus 2x cubed. Okay, and all you do, combine those like terms. I have 5x cubed in the first one, negative 2x cubed in the second one. That's going to leave me 3x cubes. Then this is my only square term, so it doesn't even have anything to combine with. It's just going to sit there, 3x squared. And it actually looks like the same thing for my x term. That's the only x term there. So it's going to sit there. And then finally, negative 1 plus 3 will give me a 2. So when I say add, again, literally all I'm talking about is adding those like terms together, combining the like terms. Subtraction is almost the same thing, okay? So here, this subtraction almost works the same way, with the exception of what I would like you to do is please remember, distribute that negative. So for these minus ones, it'll help you not make careless mistakes if you take the couple moments to just rewrite this problem, distributing that negative to every term, flipping the sign of everything in that second parenthesis. Again, taking the moment to do that is going to alleviate any careless mistakes that you might make. Because now from this point on, now it's just what we were doing before, combining like terms. So I have a 4x cubed and a 1x cubed, which together will give me a 5x cubed. This time I don't see any x squareds, so I'm just going to jump to my x's. I have negative 9x minus 4 more x to get a negative 13x. And then I have 5 plus 2 to give me 7. So again, almost same thing with the exception of having to distribute that negative throughout. All right, so that's the brief summary we have of naming, adding, and subtracting. The next big idea we covered in this chapter was the idea of multiplying. And we had two ways of multiplying. We had distributing and we had foiling. Well, remember, distributing came into play when we had just a monomial term multiplying into a parenthesis. And remember what this was, is we talked about, we multiplied the coefficients, or just the normal numbers that you see. And when you're multiplying, remember this is where we add exponents. So this, it might help you too, to consider that a 3x to the first, because that'll help you as you're working with these powers, okay? So let me restart this. So we talked about having 3x to the first there. Well, 3x times 2x squared, again, we multiply the normal numbers and then add the exponents together. Do that for the next one too. And the 7x, remember, is also 7x to the first. So we multiply those normal numbers. 3 times 7 is 21. X to the first times x to the first. Add those exponents to get x squared. And this last connection, 5 times negative, or 3 times negative 5 is negative 15. And then the x just kind of carries along for the ride. So distributing, pretty basic. You've been doing it since the first month of this class. But just remember, you multiply the normal numbers, the coefficients, add the powers together. So after we distributed, then we talked about the idea of when you're multiplying two binomials together, that's going to be this foiling idea, okay? So foiling consists of the same idea, but now we have those 4 steps, right? We multiply the first things together. 2x times 3x would be a 6x squared. Outside, so 2x times 5 is 10x. Inside, negative 1 times 3x is a negative 3x. And last, negative 1 times 5 is a negative 5. And at this point, once we got all of those, remember then we could combine like terms. So here the 10x minus the 3x would give us a 7x. And of course, we could do the same thing on the next one as well. So here 2x times 2x would be a 4x squared. Now, watch this neat trick. 2x times negative 5 is a negative 10x. 5 times 2x is a positive 10x. So if you remember, later on in the course when we had to do that, I just said, hey, don't waste your time even showing me that, right? You know they're going to cancel off anyway. So in this case, you wouldn't even have to write that down. You would just need that negative 25 out back. So remember that cool nature when they look the same except the opposite sign? Those two middle things actually end up canceling off. So all you're left with is 4x squared minus 25. And then that last one. Whenever we had something squared, remember that last one, the trick I asked you to do is to expand it out. Okay, so 3x minus 4 squared really means 3x minus 4 times itself. And once we recognize that, then we recognized, hey, this is a foiling problem. So here we have negative 12x, another negative 12x, a positive 16. And then, of course, we combine our like terms. Negative 12x and negative 12x, that gives us a negative 24x to wrap up our problem. And then there was one more kind of multiplying. So it sort of felt like distributing and foiling, but subtly it was different when we had to multiply a binomial into a trinomial, okay? It got to be a little bit messier because technically foiling doesn't work, right? We can't do that first outside inside last. And it's not just distributing either, it's kind of this blend of the two. So what I always do is I think of distributing the first term here to everything in that other parenthesis. So 2x to the first times 2x squared. So that would give us a 4x to the third. 2x times 3x would be a 6x squared. 2x times negative 5 would be a negative 10x. So I distribute the first thing to everything in the second parenthesis. And then I do the same thing with the second thing. I distribute it to everything in that second parenthesis. So we get a negative 6x squared, negative 9x, and plus 15. And from here, now it's just combining our like terms together. So here, this is the only cubed term. This is kind of cool. 6x squared minus 6x squared, so that's actually just gone. Negative 10x minus 9x would be a negative 19x, and then that plus 15. So then that was the final and only really complicated multiplying problem that we went through, is a binomial with a trinomial. So then, of course, once we mastered all of those multiplication skills, then we started talking about, well, how do we rip them back apart again? And that was the idea when we covered factoring. Factoring was the process of ripping these back apart, okay? And we spent a long time on these factoring skills. So when we say factoring, there's a couple different things that we can mean. The most basic form of factoring is when you're literally just pulling out a GCF. And by pulling out a GCF, all that means is find the number that divides, the biggest number that divides everything, and then how many of the variable can you pull out? All right, so here, this first example, 3x minus 18. Well, 3 divides both of those, so I can take a 3 out. But then the x is only in one of the terms. The x would have to be in every term for me to be able to factor it out. So really the only thing that factors out is the 3. And now just picture, well, 3x dividing the 3 out would just leave an x. Negative 18 dividing the 3 out front would just leave me a negative 6. For the next one, both 2 and 14 are divisible by 2. And this time, the x squared and the x, there's an x in both terms. And what that's going to do is that is going to let me take out the x as well, factor the x out. So when I do that, 2x squared divided by 2x, well, 2 divided by 2 is gone. X squared, take one of those x's away, just leaves me an x. 14x divided by 2x. Well, 14 divided by 2 is 7. X, take away that only x to pull it out front. Now the 7 is just by itself. And the next one, 5, 20, and 15 are all divisible by 5. And also notice, one of those terms is missing its x. So here actually no x's can be factored out because you would need an x in every single term to do so. So here, all I can do is take out that 5 and be left with that. All right, so again, that was factoring at its very basic, okay? Well then, Then we dove into that two parenthesis factoring. When we have a quadratic trinomial, we use two parenthesis factoring. I remember when we got started at this idea, we kept it very, very easy, right? We left it where that x squared was literally just there. Because remember, it's always easier when that first term is 1, right? We always reference a equaling 1. That always made this an easier process for us to manage. So remember, to do this, to get these two parentheses, remember, x times x is the only way to get that x squared. So that was always really easy for us. Now we go look and see, well, this is positive. So to multiply to be a positive, that means we need two numbers of the same sign. This tells me that sign is positive. So that's how I know that I need two positive values. To get 20, well, there's a couple ways to get 20. 1 and 20, 2 and 10, 4 and 5. So I start looking at the ways to multiply to that last number. Then I start looking for how can they combine to give me 9. Well, the 4 and the 5 are what multiply to give me the 9. And so I'm done. We can do the same thing right here. So the only way to get that x squared is with an x times an x. This being positive tells me I need two numbers of the same sign. This tells me that sign is negative. So I have two negative values here. Ways to multiply to 12. Well, 1 and 12, 2 and 6, 3 and 4. And this time it looks like the jackpot is the 3 and the 4 because those will add to -7 for me. When I'm looking at this next one, again, x and x are the only way to get to that x squared. This time, this is negative. But the only way to multiply to a negative is to have two things of opposite sign. Okay, a negative and a positive will allow me to multiply to a negative. 24 has a lot of combinations. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So now the way, if I take one of those as positive, one of those as negative, the way to get to a positive 2 is if I have a positive 6 and a negative 4. That will leave me with a positive 2 result. So that was factoring into the normal two parentheses style at its very basic, okay, when a was 1. But then, of course, there were circumstances where a was not 1, okay? So remember, that made it a little bit trickier to manage. So here, when I'm talking about a not being 1, is the way to get a 2x squared is this time I need a 2x and an x. That's how you multiply to a 2x squared, okay? So to multiply to a -3, well, that means I need opposite signs in there. Now, at least the nice thing is the only way to multiply to 3 is 1 and 3. So that's kind of the redeeming feature of this. But I don't know which one is negative, and I don't know where it goes, because putting it with a 2x is different than putting it with the x. So here we do have some choices we're going to have to make, okay? And those choices come from just trial and error. All right, so I'm going to put in the 1 and the 3. And remember, in these, it's the outside-inside connection that gets you what you need. What I mean by that is this is a 1x. This is a 6x. We already talked about that. We know one of those has to be negative because of this. So if I make this negative, that will get me the -5x that I'm shooting for. So I actually need a negative here, a positive here, and that gets me what I need. Remember, this time when a is not 1, what I need are for those connections to give me the proper pieces. All right? Same thing over here. Okay, so here to get an 8x squared, well here there's actually two ways to get an 8x squared. You could have 8x and 1x or 4x and 2x. So even here we have a choice what to put first. I'm going to run with the 4x and the 2x first. If I can't make that work, then I'll go back and I'll try the 8x with the 1x, okay? It's your choice which one you start with. You may just have to play around with it a bit to see how you can get it to fit together. So here, that positive, to multiply to a positive, we need two things of the same sign. This tells me that sign is positive. So at least here I was kind and I gave you two positive things to look for. Multiplying to 5, well, thankfully that's relatively easy, right? Multiplying to 5, there's only one possibility, a 1 with a 5. And now we just have to check. So here this is 2x and 20x. Uh-oh. 2x and 20x don't give us that 14x that we're shooting for. So in this instance, what I tried didn't work. So what I'm going to do is I'm going to try flipping those. So let's try flipping the 1 and the 5 and see what happens now. So this gives me 10x. That gives me 4x. Oh, there we go. There's the 14x I was looking for. So remember, you may have some finagling to do to get to the right thing in the end, okay? So that was factoring when a was not equal to 1. Well, then, of course, we still continued our factoring adventure with some special cases, all right? Some special cases, first meaning the difference of squares pattern. And that difference of squares pattern, remember, you always end up with a plus and a minus. So here, this is a perfect square. That's x and x. This is a perfect square. It's 9 and 9. So remember, when you're subtracting two perfect squares, it gives us this opposite pattern, that plus and the minus. So we have the x's out front, 9's out back, and that's literally just how it'll factor. Remember, it's super, super easy, but unfortunately, that also makes it super easy to forget how to do. This one is the same thing, 9x squared is 3x and 3x. 49 is 7 and 7. So again, we are subtracting two perfect squares. Therefore, that gives us this difference of squares pattern that's opposite in nature. The 3x and 3x go first, 7 and 7 go last. And then the last thing, we've already sort of covered this. When you pull out a greatest common factor, all right? So pulling out the greatest common factor, in this case, hopefully you guys can see pulling out the greatest common factor would be pulling out a 3. And sometimes when you're taking out that 3, sometimes you're left with something that can factor again. Okay, so here, that parenthesis actually can still break down into our normal two parentheses. X times x will multiply to x squared. To multiply to a negative, we need a positive and a negative. We need two oppositely signed things. And if I put a positive 3 and a negative 2, that'll multiply to negative 6. 3 plus negative 2 will leave me with that positive 1 that I need. So lots and lots of cool, fun factoring methods that we have to make sure we remember to tell apart on how to do each one. So thank you for watching this. Now what you're going to do is going to go back into Schoology and you're going to take the quizzes associated with each of these learning targets to see how will you remember this now after reviewing with me. So again, thank you for watching. Now go and take those Schoology quizzes.